Writing formulas for ionic compounds. So if I told you you had calcium and iodine, and I want to know what the ionic compound that's formed is, I want to know the name and the formula. This is what you would do. First thing you do is you always write the metal first. So write down Ca and then I. Next, you're going to write the ionic charge above each symbol. And you may ask, well, where do I find this ionic charge? So you're going to need your periodic table, and you find calcium, for instance. When I see calcium in the top right-hand corner, it says +2. And even if you can't read it, it's pretty easy because the first column is +1, +2, +3, etc., etc. So if it's in the second column, we know it's going to be a +2. So what you do is you write a +2 above it. Iodine, you're going to do the same thing. So you look at your periodic table, you find iodine, which is right here. Look in the top right-hand corner, and it says 1-. And it's doing the same thing the other side is in reverse. So remember, noble gases are neutral, there's no charge. So we have -1, -2, -3, -4. It goes the other way. So on the left side of the periodic table, they're the pluses. On the right side, it's the minuses. The nonmetals gain electrons, and that's why they become negative. So let's just go back a step. We write down the symbol, we write down the charge above it. Then you do this cool thing called crisscross, right? Where the 2 comes down here and the 1 comes down here. And we end up with Ca1I2. Now, in math class, we don't always write down like 1x or 1y. We just assume that the 1's there. So you just write down x or y. And in chemistry, it's the same thing. We don't actually leave the 1 there. Okay, if there's no 1, we assume there's 1. Okay, if it's any other number, then you have to put it in. So we have CaI2. So CaI2. Now the last thing says divide by the lowest common factor. And this is not an example one of those, but if you had like a 2 here and a 4 here, you can almost like common factor it down. And we'll run into some examples like that soon. Next thing we need to do is be able to name the ionic compound. Now remember, ionic compounds are formed when a metal gives up electrons and a non-metal gains electrons. So the metal name stays unchanged. You always leave it exactly as it is. The non-metal, just like before when we're just looking at the names of the ions, the ending changes to "ide." So we always write the metal first. The metal name is the same. The non-metal, this used to be iodine, it becomes iodide. Okay, so let's look at our periodic table. All the metals, all the blue ones, stay exactly the same. Okay, it's always lithium, beryllium, magnesium, cobalt, iron, gold, silver, potassium. Okay, those are all metals. Their name stays exactly the same. But the pink ones, the ending changes to "ide." Okay, so it's like carbide, nitride, oxide, fluoride, phosphide, sulfide, chloride, bromide, iodide. Okay, and there's not that many of them to actually remember. Okay, I've pretty much listed all of them. So it's all these little pink ones, not the noble gases. Okay, it's all the little pink ones. The ending changes to IDE. So metal stays the same, but the non-metal ending changes to "ide." So this example becomes calcium iodide. Determine the chemical formula and name for the compound formed by the combination of aluminum and oxygen. Now this is going to be an ionic compound because I have a metal and a non-metal. The metals tend to give up electrons and the non-metals gain electrons. So when we looked at our steps, the first step was to write down the symbols. So I know aluminum is Al and oxygen is O. The second step said to write down the charge above it. And you may ask, where do I find the charge? Well, you go to your periodic table. When I go to my periodic table, aluminum has a charge of -3 at the top. So you just look at your periodic table, the top right-hand corner has 3-. That means aluminum is going to give up 3 electrons and become positively charged. So we're going to write down 3+. Oxygen, on the other hand, is a non-metal, and it has a charge of 2-. 2 minus means that it's gained 2 electrons. So you write down 2 minus. Next step is super easy. It's that crisscross thing where the 3 comes down here and the 2 goes down here. You also drop the plus and the minus. There's no need to keep writing out that plus or minus. So we need 2 aluminums, so it'll be Al2, and 3 oxygens in order for everything to have a filled outer shell. If you don't have 2 aluminums, 3 oxygens, it's not going to work. You need to have enough. Now, to name this, we start with the metal. The metal's name stays exactly the same. So you just write down aluminum. And the oxygen, because it's a nonmetal, the ending changes to "ide", so it becomes oxide. So we have aluminum oxide. Let's try another one. I want to figure out the chemical formula and the name when we react magnesium and sulfur. So the first step is to write down the symbols for each. The symbol for magnesium is Mg, and the symbol for sulfur is S. Next, we have to write the charge above it. So we have to go to our periodic table. I've included one of the previous notes, a periodic table. That's okay if you didn't want to print out. Just go on the internet, lots of periodic tables there. All right, so magnesium has a charge of +2. Remember, this goes +1, +2, +3. So the second column is going to be +2. So what we do is we write down 2+. Sulfur, on the other hand, noble gases are neutral. This is 1-, 2-. Sulfur has a 2-. So we write down 2-. Next, we do that crisscross. This 2 comes down here. This 2 comes down here. We drop the plus or minus, and we write out our formula. So we have Mg2S2. Now, I noticed something, okay? They both have a 2. I can actually divide out a 2 out of both of these. So it's kind of like fractions when you put it into lowest terms. Up here, nothing goes into a 2 and a 3 evenly. But when I have 2 and 2, I can divide by the lowest common factor, which is going to be a 2. Okay, which in this case happens to be a 2. And when I do so, well, 2 divided by 2 is 1, 2 divided by 2 is also 1. I end up with just Mgs. Now, to write the name out, magnesium was the metal, so the name doesn't change at all. It just stays as magnesium. And sulfur becomes sulfide. We have to change the ending to IDE. So it becomes sulfide.